from there. So like I promised, we're not here to learn hardware, software, but it's good to have a background information, because at the end of the day, all we are going to do is we're going to be creating pieces of art. The way I write my code will be different from the way you write your code, because there are so many ways to get to your destination. You might be going left, right, right. I might be going right, right, left, and we'll still get to that same destination. So that's why it's art. Because when they ask you to paint a man, the way you paint a man is different from the way I'll paint a man. But at the end of the day, the man is going to have a head, eyes, hands, legs, and so on. So it's a sequence of instructions that you're giving that gets stored in a memory and gets executed in the CPU. All right, let's carry on from there. So why do we need to code then? Okay, we need to code because we want to get tasks done. We want to solve problems. Most of the time, people write code because they want to solve their problems, but then they realize that it's useful for others to also be able to solve problems in this way. If I know how to create a tire for a car, I just have to make that available for everybody else. Then they don't have to go and reinvent the wheel. Okay, so you produce solutions for yourselves based on a particular problem that you encountered, and those solutions get shared, and it's available for everyone. So again, coding is because computers cannot learn our language, but we are smart enough to learn ones and zeros. Because at the end of the day, when we looked at, let me go back a little bit. When you look at the CPU before, back in the days in the 60s and 70s, there used to be entire cabinets. Entire room of cabinets is what gives you the CPU. But why is that? Because it's pretty much the presence of electricity going through cables, through wires, gives you the 1, and the absence of electricity gives you the 0. So as time went by, these transistors, capacitors, and cables or wires got smaller and smaller. Guys figured out ways to make them smaller and smaller. All these Apple, Microsoft, Windows guys, that's what they did to be able to make sure that those computers that filled up entire rooms can now actually be in a cell phone. The cell phone does have exactly all of those because they figured out ways to merge millions and millions of transistors to tiny little chips. That's how we started out with Pentium, Pentium 1, Pentium 2, and so on and so forth. Now you have dual core, quad core, and so on. So their computers cannot learn our language, but we can learn how to write code, which would be translated to ones and zeros. Python is just one of the many programming languages out there. There are countless programming languages. But Python translates your code just like an interpreter. When you speak in your dialect, somebody changes it to English, or you speak in French, somebody changes it to Spanish. Python interpreter sits between what we are going to type and then translates it to ones and zeros for the computer to do it. Ones and zeros is what is known as machine language, because a machine understands presence or absence of electricity. Does that make sense to everybody?
Yeah, it does.
Awesome. So yeah, at the end of the day, that's what coding is. It's nothing more than that. Coding is just you sitting between me and your grammar, so that when I speak in English, you can explain to your grammar in the dialect that this is what this person is saying. When your grammar speaks in a dialect, you can explain it to me that grammar says you're a very handsome boy, right? Except you guys don't think that, but I don't know. Anyway, but why do we choose Python? There are many, many features that Python has that makes us prefer to choose Python. Okay, it's easy to write. When I say easy, it's literally easy to write, just like English language. Okay, it's also easy to understand, because if you see some codes out there, back in the days, assembly language, which is low-level code, and Python, which is high-level code, you can look at Python and have an understanding of what the code is trying to do. But before, when you see 10011100, you have no idea what's going on there. Okay, and when it's object-oriented, that means it relates to real-world scenarios. Just like you have a car is an object. You can say this car is of year 2020, it's of color red, it's of model coupe, and so on and so forth, brand, and all those different things. So there are countless features that Python has, okay? It's also very extensible, very portable, and scalable. You can integrate it in many places, and most importantly, it's free. Who doesn't like free stuff? It's free and open source, okay? So those are some of the reasons why we code and why we choose Python over many other programming languages. But what is Python? What exactly is Python? Is it a snake, or is it, I mean, I can tell you a lot of things about it, who discovered it and all whatnot, but that is not of the essence right now. Anyone can read up on that. But a few things that we need to point out are that Python is a language of the Python interpreter. Like I said earlier, the Python interpreter is what sits between you and the CPU, that it actually goes about the translation and interpretation of the code to make sure that it becomes machine readable, okay? It has dynamic semantics. We'll talk more about this later on. Most other programming languages, when you want to write something in, you have to define every single thing you're writing, and it cannot change. It's static. So if you have static type, for instance, if I'm going to a bank to open an account, if this bank says once you open a savings account, you cannot change it from a savings account, that's what it's going to be. It's going to stay that way. So for instance, I go into the bank and I say I want to start saving stuff in the vault, and they'll ask me, what are you going to save? I'll say, you know, I have some important documents that I like to save, maybe certificates and so on and so forth. And they say, okay, guess what? We're going to give you a drawer. You're going to save your certificates in a drawer. And then I come back tomorrow and I said, you know what? I'll also like to save, you know, I found some, you know, gold behind my yard when I was digging up. I want to start saving my gold in there. They'll tell you, no, you cannot change this size because it's static. But with Python, it's dynamic. At that point in time, you can say, you know what, rather than giving you this drawer, we're going to give you this room. You can go ahead and take the room, the entire room, and save your stuff in there. So that's what it means by Python is dynamic. Okay, for some people, it might be good. For some, it might be a problem. OOP in here stands for object-oriented programming. Like I pointed out earlier, Python relates to real-world scenarios, objects, okay? Everything is an object in the world of Python. And in that way, objects have two things. Objects have attributes, what they have, and they have methods, what they can do. Okay, so what you have are attributes, what you can do are the methods. For instance, a car has attributes. A car has a color, a year, all those information. The car can also do stuff. The car can drive forward, it can reverse, you can honk the horn, and so on and so forth. So those are some of the things that Python has that makes it different. Now, it's a general purpose language and also high level. When you say high level, it means you don't really need to write your code in machine friendly way, because there's low level code, which is machine code. And then there is also middle level, and which is assembly code. You know, back in the days, they had to write assembly language. But high level, you just write it in regular English or whichever word you want to use. And then it gets broken down using the interpreter to the low level language. Okay, it might be slower compared to machine language, because machine language does not need someone to translate, but it's a lot easier for humans to write, read, and do. Okay, so there are a lot of applications, as I listed earlier, in the world that you actually use Python for. You know, the big one here is data analysis, as you can see, whether it's data science or it's databases or it's data analytics and so on and so forth, and also web development. Okay, DevOps is something that's growing very much. Systems admins, whether it's Linux systems or it's Microsoft, whichever system it is. And for automation, okay, it could be home automation, it could be whichever type of automation. And you can use it to also scrape websites, be able to go out there and fetch information. For instance, machine learning, which is a superset of artificial intelligence, which is something that everyone nowadays is talking about, ChatGPT and so on and so forth. For educational purposes and so on and so forth, you know, there are bunch of uses for Python that it's very powerful for you to have this on your resume. You stand out, okay? And not just when you talk about Python. Now you understand the semantics, what's going on behind the scenes, the background of what Python is. Based on that, you have a better understanding. You can explain yourself and you can have a better understanding of what your code is trying to do and what it cannot do. Does that make sense to everyone? I know a lot of talking. What questions do you have? Please go ahead and let me know. No questions, and if any questions come up, do well to raise your hand and I'll definitely address your questions. So that's it. We've been able to answer a few questions so far. Let's see what else we can answer. Python has many distributions. Like we said, you know, Python is a programming language. When we say a distribution, does anybody know what a distribution is, for instance? I know if there are some Linux admins in here, you probably know what a distro is, right? The short form for distribution is a distro. You might need to unmute if you want to speak up, and there's no wrong answer. If you have an idea, vague idea, then we can talk about it.
Should it be like flavors of different things?
Definitely, that's a flavor, right? So let's take, for instance, with Windows. Many people are familiar with Windows, right? Windows systems, when you go and buy a computer, you have to decide, you know, or well, normally you don't have to decide. They'll tell you this computer uses Windows 10, Windows 11. You know, if it was back in the days, maybe Windows 95 when I started using computers, Windows NT, Windows 2000, and so on and so forth. Those are different versions. When Microsoft creates their computers, right, they create their computers with an operating system. So the computer has a platform. A platform, think about a stage. When you go on stage, that stage has a platform. On that stage, you might have Petit Pay come to the stage and sing and go. You have Ted Boulay come to the stage, sing and go. Rihanna will come to the stage, sing and go. Those are all people coming to the stage. It's a platform. So operating system is a platform. With Windows, you have with PCs, you have Windows operating system, right? With Macs, you have the Mac operating system. Linux also has its operating systems. But when you have a company like Linux, which has open source depending on Unix, they might decide that they want certain things to be packaged together with their operating system when they ship it out. So think about Brasseries du Cameroon. Maybe you have a certain brewery. In that brewery, they're going to decide that we're going to package sweet drinks and send this one out as Gino cocktail. Package these drinks and send it out as Beaufort. Package these drinks and send it out as 3 Export. Those are different distributions. Those are different flavors, like you said. With Python, there's a standard version, which is CPython. It's built on the C language, okay? But you also have different distributions. If you like to be using Python for commercial reasons and to do scientific stuff, maybe data science or analytics and so on, then you probably want to go and use the Anaconda Python distribution. If you're going to use it for data scientists or enterprise stuff, then the active Python distribution will work for you, because all of these other distributions depend on CPython, okay? So when we want to install Python, we need to know what distribution we are going to install on our computer. If you're looking at a Mac operating system comes with Python pre-installed. That would be the CPython, which is the standard version. Linux operating system also comes with the standard Python version installed. But for Windows, Windows does not come with standard version installed, so we'll need to get some kind of version of Python to install on there to utilize it. Does this make sense? Good, good, good. Okay, good for the thumbs up. Yes, question. Go ahead with your question. Yes, Nigel, you can go ahead with your question. You have to unmute. There you go.
Yeah, my question is which shall I say flavor or distribution of Python is the most popular one, like the one that is mostly used by other companies? You know how, for example, we can say Toyota is the most, when it comes to cars, we can say Toyota is the most used cars all over the world kind of thing. I was just thinking like, okay, flavor wise, which one is the most popular? Which flavor is the most popularly used? I was just curious.
Very, very good question. Which of these flavors is popular now? I will have to give you the $1 million answer on that one. It depends. Why do I say that? It depends on which environment you find yourself in. Okay. If you're in a situation or a company that's working on Microsoft Windows, then you probably find WinPython. That's going to be popular. If it's a company that works on maybe mobile applications and thinking about portable systems, then they'll probably be using Python Portable, which is self-contained for mobile, self-contained system per se. But like I said, all of these flavors are derived from CPython, except say you are working in a company that uses Java to build everything. They use the Java ecosystem for all their software and so on and so forth. So they depend on the Java virtual machine. So they'll definitely be using JPython or Jython. If it's Ion, if it's .NET ecosystem, which is also another Microsoft stuff, then Ion Python. But Anaconda Python is probably the most popular. Why I say that is because it comes pre-packaged with a lot of math, science, data science, and statistics stuff. And as you can see previously, let me go back a couple slides, permit me. Data analytics is the most popular area where Python is being used. So in data analytics, most people are going to be using Anaconda. So that again takes a bunch of that. But if it's for educational purposes, maybe less people are using the other flavors of Python. But CPython is a standard. Anaconda Python will probably be the most popular. Does that answer your question?
Yes, it does. And I had a follow-up question. My follow-up is which one are we going to be learning in this class? That was my follow-up question.
Excellent, excellent. So all of them have the same syntax. Let me just make that clear. All of them have the same syntax. It just depends on which runtime environment you're going to be using. So at the end of the day, when you look at distributions again, whether you're going to be drinking whichever type of drink, you will still be using the same cup or the same glass or the same, bottle. Okay. So CPython is just the distribution that everything resides on. But when we want to install Python, if you're going to be using Windows or Mac or Linux, all the Python that we're going to write is going to be the same. It's going to be the same language, but the person that's going to be translating it behind the scenes is going to be different. Okay, does that make sense?
Yes, it does. Thank you.
Awesome, awesome. You're welcome. I had another hand up. I think I might have missed it. Does anyone have another question? All right, yes, Aaron, please go ahead.
Yeah, are we supposed to know what distribution we are using?
Very good question. We are really not supposed to know what distribution we are using, but what I'll do is I'll give you guys the link to read up more on this at your leisure. You don't really need to know it, but it's something that's useful to help you open your eyes to what exactly it is that we're learning in Python. And in case you go to an interview, or if you see someone has a post out there for a job and they say, hey, they need you to know this and that and that, okay, it gives you an idea to know that, okay, I don't know CPython, or I have never used Jython, because Jython is a Java version of Python, but I've used CPython in everything that I know. Okay, so here is the link. I'm going to share it with you guys in the chat. So let me post that in there. You can go directly to it. It's from InfoWorld. It actually breaks down all these different flavors of Python. Okay, so as you can see, CPython, you can read more on the use cases, the limitations, and Anaconda Python, the use cases, limitations, and so on and so forth. Okay, so there's a ton of them. We don't need to go through all of them, but if you need to read up more on that, it gives you an idea what exactly is a distribution and how Anaconda Python, the separate use cases, as you can see, is for math, statistics, engineering, which is the most popular of all the uses of Python. Does that make sense to everyone?
Yep, thanks.
You are welcome. So
quick question. So
yes, go for it.
On that last slide, yes. The WinPython for Windows users, for example, I will be using Windows. Yep. If I install that, will I have the options to cherry pick, like, yes, I'm picking WinPython, but I want Anaconda version, or it comes pre-packaged with all of all of that? I'm not sure.
Excellent question. No, I love that question. So when you want to install Python, which was going to be the next thing we'll talk about, obviously, let me go back to our old slide. There you go. So when you want to install Python, right, it's up to you now what version you want to install. If I go in and search on python.org, obviously, they're going to give me a standard version of Python. Okay, so if I go to python.org and I want to download, it's going to tell me, give me just the standard version of Python. If I need to get the Anaconda version, I need to go to Anaconda, and then you see Anaconda products distribution. This would be the Anaconda version. If I want WinPython, I'll have to go to WinPython and so on. So it's up to you to decide whichever one you want. But like I said, in here, you can see the use cases. Anaconda, again, is pretty popular because it comes with all of these SciPy, NumPy, Number, all those libraries, which we'll talk about, libraries and packages shortly. So depending on what thing you want to use Python for, because Python is used for so many different things. If you want to use it for visualization, then you have to use the one that has visualization packages that you can leverage. If you want to use it for Windows products, then you have to go look for WinPython. If not, just get your standard CPython. With that standard CPython, you can add your libraries individually. Does that make sense?
Yes, I'm happy to have that flexibility.
Excellent. So we know, for instance, in Africa, we have different flavors of jollof rice, but the base is rice. The rice must be there. So CPython is just like the rice. If you decide that you want to cook Senegalese jollof rice, then you have to figure out what different ingredients that you need to use to be able to get Senegalese jollof rice, which might be the Anaconda Python. If you decide that you want to cook Nigerian jollof rice, then you find all the ingredients that you need to be able to get that. Or maybe just go ahead and buy the Nigerian jollof rice as it is. Or if you want a mixture of both of them, then you can go ahead and get all the spices that you need to be able to make that. Does that make sense? Awesome. Good. I love those questions. Keep them coming and do not hesitate. Oops, that's not where I want to be. Do not hesitate to ask any questions when it comes up. So we've talked about those different distributions. The reason I wanted to talk about distributions is because I want us to understand that before we get to installing. So now some people might know a little bit about cloud programming. Again, cloud programming or cloud computing rather. Cloud computing is just having services that reside on someone else's computer and utilizing them over the internet, right? So we can install Python on our local machine. You can install it on your laptop, regardless of what operating system it is, because let's go back again, which I forgot to mention. Python is, oh, I don't have it on there. That's horrible. Well, I did have to mention Python is cross-platform, which means you can write the code on any platform and utilize it on any platform. Platform, again, has to do with the operating system. Okay, so if you want to install Python on Linux or Mac operating system, it already comes pre-installed. It's up to you now what version you want it to be. You can upgrade your version or downgrade and so on. The two primary versions of Python are Python 2 and Python 3. Python 2 has been discontinued. Python 2 had its end of life. I think that was in 2018. 2018. Don't quote me anyway. I might be wrong in that. But going forward, nobody's writing any code in Python 2 anymore. So maybe you might go into a job that hires you and they said, hey, we have someone that wrote a Python code. Everything was written in Python 2. Can you switch it over for us to Python 3? That's fine. All you have to do is just remember all the new additions and new features that were added to Python 3. So when installing, make sure you're installing Python 3. That's the version that you want. Now the distribution is up to you, okay? If you're on the cloud, you might be using what is known as an SDK. Does anybody know what an SDK is?
It's software development kit.
That's correct, a software development kit. So with this distribution, you then have a software development kit that is produced. A software development kit is just a set of tools. Think about it like a toolbox, okay? Back in the days when I started learning programming, you have to first buy the book. In the book, there's a CD in the book. The CD has the software development kit because not everybody is the one developing software. So if you want to learn Java, you buy the Java book, open in the back. Hopefully nobody has stolen the CD. You get the CD and put it in your computer, install it and all whatnot. Nobody's doing that anymore. All you need to do now is go to the website, click on the link, download your distribution, your software SDK is created for you in the back. So for each of these cloud systems that are cloud providers, AWS for Amazon, Azure for Microsoft, GCP, Google Cloud Computing, or Google Cloud Platform, they all have their different flavors of SDK that works just fine with their architecture, okay? So when you go on there, when you see SDK, don't get confused, like what the hell is this? They're not talking about MEDK, they're talking about SDK. So it's just a software development kit, a bunch of tools that will help you write code in Python. Does that make sense? Good. So again, installing it locally. To install Python locally, it's pretty straightforward. Like I pointed out, you can go to python.org and download it, whichever version is useful for you, or you can use it on the cloud. Personally, if you're using a Chromebook, you would have a difficult time trying to install it, and I don't want us to waste too much time with that setup. I encourage you to use either Anaconda instead of downloading it if you don't have a Windows, Mac, or Linux computer, you can just code it in the cloud. All you need to do is provide a username and password. Once you provide, sign up, which is free. Once you sign up, provide a username and password, you should be good to go. And I probably forgot my login, so that's not a big deal. But there are many other ways in which you can use Python on the cloud. You can use repo.it, which we'll talk about in a little bit. Again, this also uses Python built in, whichever distribution. I can't remember if this is CPython, but there's so many of them. There's Code Anywhere and so on and so forth. I'll give you a list of all of them in the notes, but just to let you know, there are many, many options out there for you if you want to code in Python, but you don't want to have the headache of installing it on your machine. Does that sound good to everyone? So again, a few other ones, you have Python Anywhere. From there, you can host one and code Python in the cloud. There's also Code Anywhere. With Code Anywhere, you get to choose what programming language you want to use and so on and so forth. Okay. So there are many, many options that you can use. But if you are using a Mac operating system or a Linux operating system like myself, you can go ahead and open your terminal. Once you open your terminal, to check what version of Python you have to type in Python. Sorry, let me make this bigger so everybody can see. Okay. So you have to type in Python 3, which is for version 3, like I pointed out. Python 3, a first dash and a second dash, those are 2 dashes, and then you type in version. That is going to tell you what version of Python you're running. This is currently running Python version 3.9.6. Okay, so that's how you would know if you're running on a Mac. If you're on Windows computer, what you need to do to check if you have Python installed or what version you have, you just type in Python -- version. That's what you need to type in Windows. So check that out. And you should be able to get that. Now, for those who are on the Mac, how do you open a terminal on a Mac? Let me close this and start from afresh. So to open a terminal on your Mac, what you need to do is go to Applications. When you go to Applications, you should be able to see Utilities. Under Utilities, you should be able to see Terminal. What I'll suggest you do is drag it and drop it on your dock so that you always have access to it immediately. But from there, you should be able to click on Terminal. If you are on Windows, what you need to do is go to the Windows search on the bottom left and type CMD. CMD is for command. That's going to take you to the command line or the terminal or the shell, and you should be able to go from there. Sounds good? What questions do we have? Feel free to ask whatever questions you have so I can do my best to respond. All right. So again, for those that are using Mac, you would not. Yes, I think you have a question. Fred, go ahead.
Yeah, I just wanted to ask, you said when we get the command line and then in Windows, which there was something you say with Python something to know if it's installed in Windows computer or not.
Very good. So what you need to type for Windows is Python. You give a space, and then you put 2 dashes and type in version.
Okay.
If I do that on my Mac, it's definitely going to say it's an error. Yeah, it doesn't know that. For the Mac, what I need to do is type Python 3. So I'll need everyone to at least give me a heads up. Those that have it pre-installed and those that do not have it pre-installed. For those that don't have it installed, that is totally not a problem. What we'll need to do is just go to Anaconda. When you get to Anaconda, let me go ahead and use my virtual.
I don't have it. I get a message say Python was not found. Run with that
Awesome.
argument.
So if Python was not found, what I would encourage you to do is go to Anaconda and either download it or use it in the cloud. I'll encourage you to use it in the cloud. That's fine. If you download it, that's also fine. But let's start by using it in the cloud. Tomorrow, we're going to make sure everybody has it downloaded. I can give you that as your homework to download it. But let everybody go ahead, go on the cloud. I can log in now because I already have an account. Okay. Actually, I'm lying. This is for me to create an account. Instead of me creating an account, I don't want that. I want to log in because I already have an account. So let's go ahead and log in into the Anaconda nucleus. To log in, I'll put my username and my password. It should be straightforward. So to create an account, you're going to put in your username, password. It will send you confirmation email, something like that, and so on. So it definitely takes me to the last part where I was, but I'll go ahead and start a new one altogether. All right, everybody good? So 2 things that I'm going to need from you guys before I proceed. First is for those that do not have Anaconda, or sorry, that do not have Python, you can go ahead and start downloading it. It might take a minute, but also go ahead and sign up on anaconda.com. From there, we're going to be using Anaconda on the cloud, and I'll be able to explain to you all of these when we get back. What I need you to do is go to anaconda.com. Let me go ahead and type that again. Oopsie. Go to anaconda.com, download Anaconda, and also create an account in the cloud. Okay. So for instance, I already have it, so I don't really need to, but that's fine. I'll go ahead and download it. If I click on download, it starts downloading, as you can see here. Whenever it's done downloading, that's totally fine, but go ahead and click on in the cloud so that you can also have it running in the cloud, and you should be able to go from there. Okay. So it's probably going to take about less than 10 minutes to download, and then you install it. But go ahead and also code in the cloud. When you go ahead and create a username and password, it will let you sign in. When you sign in, you should be able to see a page like this. So after the 10 minutes break, when we come back, that's where we're going to carry on from.